Yeah, I bet you didn't expect to have Buddy the Elf teaching you math today. Yeah, all right. So today we're going to learn about the surface area of triangular prisms. Triangle, you guys, this seems to be the hardest one to figure out. So you're going to do better than past students in the past year. So triangular prisms, when we're trying to find the area of just a regular triangle, remember we're looking for that 90-degree angle. We're going to take the base times the height. We don't need this hypotenuse. Say hypotenuse. Brady. Say hypotenuse? No, he's not saying. Hypotenuse, we don't need that unless we're looking for perimeter, or I guess you could use it later on, but base times the height. But the thing is, this is half of the size of a rectangle, so we need to do what? Yes, we need to divide it by 2, or we could go half of the base times the height. So there's a couple different ways. You can go base times height, divide by 2, or you can take half of the base times the height. Either one works, it doesn't matter to me when you're looking for triangles. So let's move on. Triangular prisms, when you're trying to find these, you have to find the faces. So in this one, base times height divided by 2. You're looking over here. Now the front and the back, it's going to get a little bit of a challenge to figure out which side you're using. But for these, they only have 1, 2, 3, 4, 5. They only have 5 faces. So if you find more than 5 faces, we're going to be in trouble. So you have a triangle you have to find. Base times height divided by 2. You have a rectangle you need to find. Length times width, or base times height. They're the same types of things. You're going to take this base and go times the height. Multiply those out, just like a rectangle. Now, the base here, this bottom one, the same type of thing. Length times width, or base times height. If I go length here and width here, and I multiply those out, I'm gonna be able to find the face, the area of that face, whether it's a rectangle, these two, or a triangle, that one. Okay? So, let's put this work to the work here. So, based on this one, I've got a triangle. And this triangle right here, if I pull it over here, I've got 7 by 8. 7 and 8. But remember, the formula for a triangle is base times height divided by 2. So what I can do is multiply this out, I get 56. 56 divided by 2, 28. So I get 28 for this face. Now you got to think, it's a 3-dimensional shape, right? So if this triangle is 28, we'll go say the front is 28. What's that back one going to be? Same thing, I don't have to find it, 28. Now, get rid of that. Now I'm down to the rectangles. Now the rectangles, I'm going to use this shape right here. You could probably call this the top if we wanted. Okay, this one right here. Based on this, I have a 2. And here, it's a 9. Now, the orientation is just turned. It's still a rectangle. It's still, a rectangle like this. It's just turned a little bit. Measurements are the same. 9 times 2, base times height, length times width. 9 times 2, I get 18. So this face right here is 18. And this is where it gets a little bit trickier. We're going to call that the top here. I guess we go right or left. Doesn't really matter. So 18. So now I've found 3 faces. The triangle, and then this one right here. Now, what I have to find is this bottom one. This bottom face, okay, downward here. And if I look at this, I have a 7 by 2. If I want to pull that away, I can. This is going to be a 7 by 2. Now, it looks like a parallelogram just based on the way the orientation is. And we've learned that base times height, same kind of thing, is going to give us our parallelogram height. So 7 times 2, I'm getting 14. So the bottom one, 14. Good. So I've got this face. I just got to get this back face over here. And this rectangle over here on this back side, and I know it's kind of hard to see, and this is where we got to use our numbers, got to use our vision a little bit here of knowing, all right, this one is 2, so this line over here is also 2. This height is 8, so 2 times 8, I get 16. So this left-hand side over here is 16. 16. Now I know I have 6 faces here. I use this from the rectangular prism, but I have 5 faces. The 2 triangles, which you'll always have 2, the front and the back here. And then you're going to have 3 faces. Now sometimes the faces will all be the same. Sometimes they're a little bit different. Okay? Now what do I have to do with these numbers? Please say add. Please say add. Good job. Add. I got to add all these up. Ooh, I'm going to get a calculator for that one. Ain't happening. I'm good, but I'm not that good and under pressure. All right, so pop 28 plus 28 plus 16 plus 18 plus 14, 275, no. You get 104, and these are actually labeled for centimeters, and they are squared. So again, I have to find the area of all the faces. There are 5 on this one. And then go about it. Add them all up. Let's try another one. I fooled you. Okay, so this one's a little bit more unique. You have to visualize where these lines are going to be. Okay, based on there a little bit, visualize a little bit. But I have a front triangle, I have a back triangle. So I'm going to help me visualize this. This triangle right here, remember I don't need the base, which is 6, the height, which is 3. I don't need this height, this side over here, 7. I don't need that number for when I'm finding the area of a triangle. I know the area of a triangle is base times height divided by 2. Well, base times height, 6 times 3 is 18. 18 divided by 2, 9. 9er. So I'll get a triangle of 9. And the other triangle on the back side is going to be the same thing. It's going to be 9 as well. 9. So the front, 9. Backside, 9 as well. So now I'm going to try to find the area of this particular face. And based on this, if I take this shape, I have a 12 long, and right here it's 7. 12 times 7, I get 70, 84, Randy Moss, 84. So the right-hand side, let's go 84. I'm assuming, being this is an isosceles triangle, 7 and 7, not equal out, or about 7 and 7, this other side is also going to be the same measurement. Because this is 7, this is 7, it's still 12. So I know that that left-hand side over there is also going to be 84. Okay? Now, the only one we haven't found yet is where? The bottom. Okay? And again, I'm going to draw some dotted lines in there. Okay? And I'm looking for this face, the bottom of your tent, where you put your sleeping bags. Okay? This face down here, now based on that, it's going to be 6 by 12. Well, 6 times 12, 6 times 12, I get 6, 12, carry the 1, 6, 72. So that bottom is going to be 72. And there's not really a top of this tent, so we don't need that one. Remember, there's only 5 faces. The triangle, the side, and then the bottom. These, I add all these up, and if you notice, these numbers are a little bit wonky here, so I'm going to add all these up. I get 18 plus 72, that's probably 90, but, you know, I just want to make sure. 18 plus 72. I know, some of you already have it done in your head. Plus 84. Plus 84, 168. 168, they're meters, and they are squared because it's area. We're not dealing with volume yet. I think we got this under control. If you're not sure, think about it as the net. If I was to unfold these, what would that look like? They could look like this shape. They could look like this if I unfold them. So the nets may be able to help us find these as well. Okay? You guys, you're going to go on to IXL. IXL is 6th grade. Make sure you go to 6th grade. I know you're able to do it. I know you're only 5th graders, but you are able to do this. 6th grade, go to double F 18. Double F 18. Try to get 80%. Tomorrow we're going to combine both the lessons together and just kind of remind you, a little bit of review, and then we'll move on from there. See you later. Bye.